Okay, a quick reminder of phasor diagrams and using them in AC circuits. So for a resistor in an AC circuit, okay, this is the current, this is the voltage, and the voltage is the same as the voltage there. Okay, the way that we represent it is, if this is the voltage, then the current is exactly the same phase. So we can draw just there. It can be directly over the line, it doesn't matter. And which one is longer doesn't really matter because one is current, one is voltage. So you just draw them together. As long as they are in phase, they'll be okay. This can be I, this can be V as well. For a capacitor, okay, so this is V, this is I now, and this is VC, same thing as well. There's only one component anyway. So remember the CIVIL mnemonic. So for a capacitor, the current leads the voltage. So if this is my current, then my voltage will be below here, VC. Okay, 90 degrees, because this is rotating anticlockwise, and so my current is ahead of my voltage. I can also draw it this way, comes to the same thing. Okay, this is my current, this is my VC. It's the same thing as well. Okay, this one just shows that it has rotated 90 degrees, a bit more anticlockwise. Now, for an inductor, I will use this here. The voltage leads the current for an inductor, L. Okay, so the VL, this is I. And so what I would do is, if this is my current, then my voltage leads the current, and so it would be up here, VL. Okay, 90 degrees. Or in the same way, I can also, if this is my VL, then my current will be down here. It's the same thing. So remember, this is 90 turning anti-clockwise, so this is 90 degrees ahead of that. Now, let's use all this and draw the phasor diagram and the impedance triangle for a series circuit. So R, L, and C. Okay, R, L, and C. Now, because it is series, it is the current that is the same through all. The voltages are all different. So we have VR, VL, and VC. Okay, but let's draw the phasor diagram. So this is my reference, and I put my reference at the 3 o'clock position. Yeah, my current's my reference. And just draw this a bit longer. So let's say this is my V resistance, exactly in phase. So following this again for my voltage of the capacitor, okay, if this is my current through the capacitor, then my voltage is downwards. So I will just draw it, let's say like this. Okay, so this is my VC, and my VL, if this is the current, my VL is upwards. So I'll just say about this much. You have to do the actual calculation, but this is just to show you an example. So who wins the tug of war between the VL and the VC? Well, VC is longer, and it wins by probably about this much. So this is my VC minus VL, or to make it shorter, I'll just call it VCL. Now, the total Vs, the power supply voltage, is the same as the voltage across this plus this plus this. Yeah, the voltage across the resistor, across the inductor, and across the capacitor. So I have already combined or added up the voltage across the inductor and the capacitor here. Okay, so these two are combined, and now I have to add it with the resistor, which is here. So I have to add this one here with the resistor voltage there. And the way that we do that is in phases, we add it up. This is how we add it up. So this now becomes my Vs. And that's it. This is my phasor diagram. Okay, for the impedance triangle, you have to calculate the XC, and that is 1 over 2 pi FC, and my XL equals to 2 pi FL. And so my XCL, that means we have to see who wins again. So the same idea, we just do XC minus XL. And I've chosen C minus L, not the other way around, because in this example, I've decided, in this example, my C is more significant. So I've just done it this way. So this is my XCL. My resistor is, my resistance is horizontal there, like this. And so the total impedance of this whole circuit, Z, is here, right? And this is my impedance triangle. Okay, and then using Pythagoras theorem, we can calculate what Z is in using this method. Okay, so that is a phasor diagram and the impedance triangle for a series circuit. Now, what happens for a parallel circuit? Same kind of idea, but we'll just apply it for a parallel circuit. So let's draw that there. So they're all in parallel. Oops. Parallel circuit, resistor, R, L, and C. Yeah. Now, because it's parallel, the voltages are all the same since they're all bridged across there, but the currents are all different. So this is IR, IL, and IC. And of course, the supply current is the same as IR plus IL plus IC, but added up using phasors. So let's draw the same thing. Let's draw the thing again here. What is the same? It is the voltage that's the same. So I'm going to draw that at the 3 o'clock position. Okay, this is my voltage, my supply voltage, which is the same for all of them anyway. And okay, so I'll just draw a circle to remind us that we're using that as a reference. Now, this will be the current through the resistor. Current through the inductor, let's see, using this, if this is V, then my inductive current is down below here. So I'm just going to say my inductive current is here, IL. And so my IC, we will use it for this method, is up here. And I'll just say it is here. Okay, IC. So who wins the tug of war between IL and IC? Well, IL wins by, I would say, this much. So this is IL minus IC. Again, in this example, I'm saying that the inductive current is more significant. Okay, you have to do the actual numbers to find out. And so I've combined IL and IC here as this phasor. And now I have to add it to the IR to find my total supply current. And how do I add phasors? Well, it is like this. And this is my, let's draw that again. So this is my IS. So this IS adds up the IR as well as the IL and IC. And that's it. That's my phasor diagram. Done. Okay, to calculate or to draw my admittance diagram. So it's admittance diagram for a parallel. So remember my conductance is 1 over R. Okay, and then I've got my susceptance. So my BC is 2 pi F. Oops, pi's got only 2 legs, not 3. 2 pi FC. And my inductance is 1 over 2 pi FL, right? And again, in this case, my inductive value has more significance, is larger. So, oops. So to combine it, what's my total? Who wins the tug of war again between these two? It is BL minus BC, and you have to do the calculation again. Obviously, if IC is longer, my BC